Good morning. And today we have our last day of review before the test tomorrow. There will be no class meeting tomorrow. Just take your final exam, finish it by 11:59 Tuesday evening. Don't bother to email me asking what your final grade is. When I've got them all calculated, I will email everybody and let them know. Okay, anyway, the following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu. and I'll respond as soon as I can. Okay, so let's get started. We're going to start out with chapter 10, which introduced, let's see, the square root property and quadratic formula, graphing parabolas, etc., etc. So we're going to start off with this first problem. It says, use the square root property to solve the equation. So we have z squared minus 50 equals 0. To use the square root property, we want to isolate a perfect square on one side of the equation, and that perfect square needs to contain a variable, and then we want the constant term on the other side of the equation. So for this problem, the first thing we'll do is to add 50 to both sides of the equation. So now we have the form we want. Next, we take the square root of both sides of the equation. Don't forget that on the right side, we get plus or minus. So now we have z equals plus or minus the square root of 50. However, we can simplify the square root of 50, so we want to do that. The square root of 50 is equal to the square root of 25 times 2. 25 is a perfect square. The square root of 25 is 5 on the outside. So z equals plus or minus 5 square roots of 2. So putting our answers in, we would have negative 5 square roots of 2. And then we need to move the cursor outside of the radical, comma, space. And then I don't need to put a plus sign, 5. Push the wrong one. Here we go. Now I've messed it all up. Okay, 5 square roots of 2. So that should give us the correct answers. And it does. Any questions about that problem? Okay, I'm going to switch it back to black ink. That tends to show up better. Let's take a look at this next problem. Actually, I'm going to skip that because that's just like the previous one. Let's take a look at problem number 3. Use the square root property to solve the equation. So we have the quantity x plus 3 squared equals 4. So it's already set up in that nice form where we have a perfect square on one side of the equation containing the variable and a constant on the other side of the equation. So we immediately take the square root of both sides of the equation. Again, don't forget the plus or minus. Square root of 4 is 2, so we get that. But now we haven't solved completely for x yet. So we'll subtract 3 from both sides of the equation. So x is negative 3 plus 2, and x is negative 3 minus 2. Well, negative 3 plus 2 is negative 1. Negative 3 minus 2 is negative 5. And it doesn't say so this time, but be careful. Sometimes it says to put them in order from smallest to largest, but it didn't ask us to. So we've got what? Negative 1, comma, negative 5. And let's see if that works out okay. And it does. Okay. Let's go down to this problem. Again, if you have any questions as I'm going along, please feel free to stop me. And let's take a look at this. It says use the quadratic formula to solve the equation. So we've got x squared plus 12x equals negative 36. To use the quadratic formula, we need to have the equation in standard form, descending powers of the variable. So I'm going to add 36 to both sides of the equation. So now A is 1, B is 12, and C is 36. The coefficients of the A, B, and C terms. X equals negative B plus or minus the square root of B, the quantity squared, minus 4AC, all over 2A. Now it's a matter of simplifying this formula. So we get negative 12 plus or minus the square root of 12 squared is 144. Minus 4 times 1 times 36 is minus 144 all over 2. So x equals negative 12 plus or minus the square root of 0 over 2. X equals negative 12 plus or minus, well, the square root of 0 is 0 over 2. So x basically equals negative 6. Okay. And it's the same solution both times, so we only need to put in 1, I believe. Let's see if it asks us to put in negative 6 twice. Nope, it doesn't. Okay, let's take a look at, let's use this one. Okay, it says 72t squared minus 46t minus 6 equals 0. This problem already is in standard form, descending powers of the variable. Let's see, all the coefficients are even, so we could reduce this thing down by dividing each term on both sides of the equation by 2. You don't have to do this, but by doing this, it makes the numbers smaller within the quadratic formula and less reduction is necessary at the end. So this is 36t squared minus 23t minus 3 equals 0. So A is 36, B is negative 23, and C is negative 3. T equals negative B plus or minus the square root of the quantity B squared minus 4AC all over 2A. T equals positive 23 plus or minus the square root of, let's see here, negative 23 times negative 23 would be positive 529. Then we've got minus 6 times 36 times negative 3, which is going to be a positive. That's 4 times 36 times 3. That's 432. And that's all over 2 times 36, which is 72. T equals 23 plus or minus the square root of, so let's see, 529 plus 432 is 961. Would be nice if 961 was a perfect square. Let's find out if it is. So we'll take the square root of that. It turns out it's 31. So that worked out nicely. So T equals 23 plus 31 over 72, which is what, 54 over 72. We can take a 9. Let's see, if we take a 9 out, we get what, 6, 8, oh, 3/4. Is that right? I think so. 9. Let's see, divide by 9, divide by 2, divide by 18. Okay. And 23 minus 31 over 72. Let's see, that would be getting sloppy here already. That's not good. Let's see, 23 minus 31 over 72, which is negative 8 over 72, which is negative 1/9, dividing the top and the bottom both by 8. Okay, so let's see here. 3/4 move the arrow over, comma, space, -1/9. All right. And let's see, let's take a look at, let's do number 9 here. It says, solve the equation, approximate the solutions to 2 decimal places. Enter your answer as a comma-separated list. Okay, so x squared equals x plus 7. So we're going to put things in standard form, descending powers of the variable. We'll subtract x and subtract 7 from both sides of the equation. So now I've got a is 1, b is -1, and c is -7. X equals -b plus or minus the square root of the quantity b squared minus 4ac all over 2a. Continuing to simplify, x equals 1 plus or minus the square root of 1 plus negative times negative is plus positive. 4 times 1 times 7, 28 all over 2. So x equals 1 plus or minus the square root of 29 over 2. But we're going to find decimal answers to 2 places. So let's see. X is 1 plus the square root of 29 all over 2. And x is 1 minus the square root of 29 all over 2. Now, recall that when you put this into your calculator, you want to put parentheses around the entire numerator as well as the radical. So I've got parentheses 1 plus the square root of 29. I'm going to close up the radical, close up the entire numerator divided by 2, and I get 3.1925, etc., etc. Rounding to the nearest hundredth, that would be 2 decimal places to the right. The 2 would round down. So my first answer should be 3.19. Okay. My second answer, I get -2.1925, etc. So again, the 2 rounds down. And let's see what happens. Okay. So I've got 3.19, comma, space, -2.19. And let's see here. All right. Okay, let's take a look at problem number 11. Here we have a quadratic equation that contains fractions. So initially, A is 1/2, B is 5/2, and C would actually be a +1 because we'd have to move it to the left side of the equation. But we can get rid of those fractions before we plug numbers in. So let's do that. Again, that should make it easier to deal with. Okay, first thing I'm going to do is I'm going to add 1 to both sides of the equation so that it's in standard form. Then I'm going to multiply both sides of the equation by 2 in order to clear the fractions. So I've got 2 times the quantity x squared over 2 plus 2 times the quantity 5/2 x plus 2 times the quantity 1 equals 0 times 2. So now going across and simplifying and reducing, we get x squared plus 5x plus 2 equals 0. Okay. So that gives us a equals 1, b equals 5, c equals 2. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. X equals -5 plus or minus the square root of 25 minus 8 all over 2. X equals -5 plus or minus the square root of 17 over 2. Well, let's see if that's any of our choices. -5, it's got to be one of these two, plus or 17. Ah, this one right here. Okay. So in that context, we can have our answers in the plus or minus form. Okay, let's see here. Let's take a look at this one. Quadratic function, its graph is a cup-shaped figure called a what? It's called a parabola. Okay. And let's see here. Lowest point of the graph, in this case, 2, 1 is called the vertex. Okay. The vertical line x equals 2 divides the parabola into 2 halves. This line is called the axis of symmetry. So there's some vocabulary. All right. Interesting. I deleted all these answers and they still showed back up. So, oh, well. Here we go. Let's take a look at. We'll take a look at number 16. Okay. Find the vertex and the axis of symmetry of the graph of the function. So we've got f of x equals quantity x minus 1 squared plus 9. Keep in mind, this is in the form y equals a times the quantity x minus h squared plus k. The vertex is at hk, and the axis of symmetry is at x equals h. All right, so for this problem, h is 1 and k is 9. So the vertex is at 1, 9. And the axis of symmetry is at x equals 1. I cannot emphasize enough the fact that on the axis of symmetry, you have to put in x equals. If you just put in 1, let me show you what happens. I just put in 1. It is incorrect. It has to be an equation, x equals 1. All right, now, does the parabola open up or downward? Because a equals 1 in this case, it opens upward. Remember, if a is positive, it opens upward. If a is negative, it opens downwards. Okay, and I know these answers keep coming back up, but I'll just keep erasing them. All right, let's take a look at this one. Find the vertex and axis of symmetry of the graph of the function. So f of x equals -4 times the quantity x plus 3 squared minus 4. So y equals a times x minus h squared plus k. A is -4, h is -3, k is -4. HK is -3, -4. The axis of symmetry is x equals h, and this thing opens downward because a is less than 0. So this is going to be -3, comma, space, -4. This is going to be x equals -3. And it opens downwards. Okay. Now let's review how you graph these things. So same form, y equals a times x minus h, the quantity squared plus k. So y equals a times the quantity x minus h squared plus k. So the vertex is at hk, which would be -7, -2. right? Because you'd have to take x plus 7 and write it as x minus -7. So h is -7. The axis of symmetry is at x equals -7. Okay, so let's put those in. Vertex is at -7, comma, space, -2. Axis of symmetry, x equals -2. Okay. Let's submit that and see if that part of it's correct. Okay, and it's, oh, I put in the wrong number, didn't I? It should have been -7. Okay. Let's see what happens now. Pay more attention to what I'm doing here, as usual. Okay, now, let's get rid of the parabola. I know the answer keeps popping up because of the mode that I'm in here. All right, now, recall to graph a parabola in Webassign, we need to find the vertex, and then after that, one other point, okay? So I'm going to click on the parabola till it's blue. I'm going to click on the vertex. Careful, my scale is in each square is 2 units. So -7, -2 would be right there, okay? But now I'm going to come over here and, oops, go back there. All right, so I've got -7, -2. I need another point. Let's just pick some point to the left or the right. How about -6? That's not a point, that's an x value, but so f of -6 is going to be -6 plus 7, the quantity squared, minus 2, which is 1 squared minus 2, which is 1 minus 2, which is -1. So now, -6, -1, right there. If I'm not sure that my points are correct, I can go over here and, oh, -7, -2, -6, 1. That should be correct. Okay. And there's my parabola. But again, you've got to plot the vertex first. Let's remind you what happens if you don't. Let's say I do the -6, -1 first. This is -1. And then the -7, -2. See what happens? It plots it downwards. Let's see if it says it's wrong. Yeah. So even though both those points are correct, Webassign doesn't know. You have to tell it which one is the vertex. So you have to put the vertex in first. Okay. So again, a vertex, -7, -2. Then another point. Make sure that they're the correct ordered pairs, and that should make it all right. Okay, what? -7. I didn't pay attention, -1. There we go. Okay, how about that? Finally, so again, pay close attention. All right, let's see here. Intercepts, X and Y-intercepts. So how do you find an x-intercept? Set y equal to 0. How do you find a y-intercept? Set x equal to 0. So if we've got the function f of x equals x squared minus 2x minus 15, f of x is just another name for y, so we'll replace it with y. So to find the x-intercepts, we'll set y equal to 0. How are we going to solve that? Well, we'll use the quadratic formula, and it's already in nice form. A is 1, b is -2, c is -15, x equals -b, plus or minus the square root of the quantity b squared minus 4ac. all over 2a, x equals 2, plus or minus the square root of 4 plus 60, all over 2, x equals 2, plus or minus the square root of 64, all over 2, x equals 2, plus or minus 8, all over 2, x equals 2 plus 8 over 2, which is 10 over 2, which is 5. So one of our x-intercepts is at 5, 0. X equals 2 minus 8 over 2, which is negative 6 over 2, which is negative 3. So the other one is at negative 3, 0. How do you find y-intercepts? You set x equal to 0. Well, let's see. F of 0 would be 0 squared minus 2 times 0 minus 15. So that's going to be at 0, comma, negative 15. Now, here's that smaller, larger value. So if I put 5, 0 there and negative 3, 0 there, even though those are both x-intercepts, it's going to mark it wrong. So I got to put the smaller one first, negative 3, comma, 0. And you got to put the 0 in as part of the ordered pair. 5, comma, 0. And then 0, comma, negative 15. So make sure you've got your zeros in the right places. Let's see if I do. Okay. All right. Let's go on down to this problem. Determine the coordinates of the vertex of the graph of a function using the vertex formula. Then determine the x and y intercepts of the graph. If an answer does not exist, enter D in E. Okay, this is not in that form y equals a times x minus h squared plus k. It's in the other form. It's in the form y equals ax squared plus bx plus c. When it's in that form, recall that the axis of symmetry is at x equals negative b over 2a, and the vertex is at negative b over 2a, comma, in other words, the same x value, and then f of negative b over 2a, meaning you take the x value that you found in the first part, plug it back into the function to get the corresponding y value of the vertex. So even though they didn't ask us for the axis of symmetry here, we do need to find it because that's the first half of the vertex. All right, so what have we got here? A is 1 and b is 4. So x equals negative b over 2a would be negative 4 over 2 times 1, which is negative 4 over 2 or negative 2. So I should say x equals negative 2 is the axis of symmetry. Again, we're not going to put that in there. They don't ask for that specifically. But now I know that the vertex is at negative 2, comma, f of negative 2. So negative 2, the quantity squared, plus 4 times negative 2 plus 4. 4 minus 8 plus 4 is 0. So the vertex is at negative 2, comma, 0. Okay. Now, x-intercepts. To find x-intercepts, set y equal to 0. So if y is 0, I've got 0, oops, 0 equals x squared plus 4x plus 4. Using the quadratic formula, let's see, we already know that a is 1 and b is 4 and c is also 4. I would get x equals negative b plus or minus the square root of b, the quantity squared, minus 4ac all over 2a. X equals negative 4 plus or minus the square root of 16 minus 16 over 2. X equals negative 4 plus or minus the square root of 0 over 2. X equals negative 4 plus or minus 0 over 2. X equals negative 4 over 2 or negative 2. Oh, what do you know? The x-intercept is negative 2, 0. Well, that's the same thing as the vertex, isn't it? Negative 2, oops, wrong thing. Negative 2, comma, 0. Why is that? Well, because the vertex lies right on the x-axis, so there's only one x-intercept. How do you find a y-intercept? You set x equal to 0. So f of 0 is going to be what? 0 squared plus 4 times 0 plus 4. It's just c. So it's at 0, 4. Okay. Now, to graph the parabola, I need to start with the vertex, which is at negative 2, 0. And then one other point. Well, the x-intercept is the same point. Oh, but the y-intercept, that's another point on the graph. And again, let's make sure my points are right. Negative 2, 0, 0, 4. So that should be correct. Let's see what happens. Okay. Let's see here. Let's go down to, let's take a look at this problem, 29. Okay. All right. A fireworks shell is shot straight up with an initial velocity of 80 feet per second. Its height s after t seconds is given by the equation s equals 80t minus 16t squared. If the shell is designed to explode when it reaches its maximum height, how long after being fired and at what height will the fireworks appear in the sky? All right, first of all, let's take our equation, which is a second degree or a quadratic equation, right? And let's put it in standard form. Okay, now A is negative 16, which means this thing is going to open downwards. So basically, it says if the shell is designed to explode when it reaches its maximum height, how long after being fired at what height will the fireworks appear in the sky? So the vertex up here at t comma s, the t time, that would tell at what time it reached its maximum height, and s, the height, would be the second coordinate of the vertex. So basically we need to find the vertex, okay? Well, this is in that y equals ax squared plus bx plus c form. So let's see, a is negative 16 and b is 80. So x equals negative b over 2a, which is negative 80 over 2 times negative 16, which is negative 80 over negative 32. Negative divided by negative is positive, and 80 divided by 32 is 2.5. So the vertex is at 2.5 comma. Let's find out what the second value is. S equals 80. Oh, wait, we're going to use this form, right? So S equals negative 16 times 2.5 squared plus 80 times 2.5. We go to the calculator. Negative 16 times the quantity 2.5 squared plus 80 times 2.5, and I'm getting 100. So the vertex is at 2.5 comma 100. Now let's go back and answer the question. So what's the time that it reached its maximum height? 2.5 seconds. What was the maximum height? 100 feet. Be sure you get the right numbers with the right labels. 2.5 seconds and 100 feet. Okay. And finally, let's do this one. Okay. All right, let's see here. From the top of the building, a ball is thrown straight up with an initial velocity of 32 feet per second. The equation S equals negative 16t squared plus 32t plus 48. gives the height s of the ball t seconds after it's thrown. So far it looks very similar to the previous problem. Find the maximum height reached by the ball and the time it takes for the ball to hit the ground. Okay, now this is different. In this top problem, they wanted the time when it reached its maximum height and that maximum height. Here they want the maximum height, which is here, and the time, not the time at its maximum height, but the time when it hits the ground. All right, to find the maximum height, well, let's see. This is a parabola opening downward again. So TS would be the vertex. We want the S, or the maximum height value. So let's find that. Let's see here. A is -16, B is 32. So we've got what? T equals -b over 2a, -32 over 2 times -16, which is -32 over -32, which is 1. So after 1 second, it reaches the maximum height, but we need that height. So then we put -1 in there, we get this, which is, let's see, -16 plus 32 plus 48, which I believe is 64. So the vertex is at 1,64, but 64 feet would be the maximum height. Okay, so 64 feet. Now, it doesn't want the time at the maximum height. It wants the time when it hits the ground. What is the height when it hits the ground? The height is 0. So we've got this equation. Oops. If I push this thing too hard, it goes to the next page. This. So now we're going to use the quadratic formula. But there's some things we can do to make this simpler. 16 goes into -16 and into 32 and into 48. So I'm going to divide everything by 16. But wait a minute, you know what? If I divided everything by -16, not only would it get rid of the 16, it would also get rid of the negative. So now I've got 0 equals t squared minus 2t minus 3. You see how this would be 1, so 1t, that would be -2, and 48 over -16 would be -3. Okay? Now I'm going to take this and go to the next page. T squared minus 2t minus 0. T squared minus 2t minus 3, I think it is. I think that's right. Let's make sure. Yes. Okay. So A is 1, B is -2, C is -3, T equals -b plus or minus the square root of b squared minus 4ac all over 2a. T equals 2 plus or minus the square root of 4 plus 12 over 2. T equals 2 plus or minus the square root of 16 over 2. T equals 2 plus or minus 4 over 2. T equals 2 plus 4 over 2, which is 6 over 2, which is 3. T equals 2 minus 4 over 2, which is -2 over 2, which is -1. So we get T equals 3, T equals -1. Why the negative? Well, let's go back to the picture. Well, I guess I don't have the actual picture, but the building, you know, we've got this thing here, okay? So T equals 3 is when it hits the ground. If we extend this parabola backwards in time, let's see here, T equals -1 would be like back over here, but that doesn't actually exist because that's negative time. So our only correct solution is the T equals 3 value. So we've got 3 seconds there. Okay. Now, the thing about this, again, that you've got to keep in mind is that these two problems are different. They're asking you for different things in This one, both of them, they want the maximum height, but here it wants the time it reaches the maximum height. Here it wants the time it hits the ground. So read the problem. Don't just look at it and go, oh yeah, it's one of those. All right. Any questions? Okay, so I am going to stop the recording.